Number 38. The normal respiratory rate of a human being is 15 breaths per minute. The average volume of air for each breath is 505 cubic centimeters at 20 degrees Celsius. Now, I already see that that's in degrees Celsius, and I don't like that. I want that to be in kelvins, so I convert that into 293 kelvins. Let's see. This is going to be a V1. We have a T1, and then a P1 at 9.95 times 10 to the 4th pascals. What is the volume of air? What is the volume of air at STP? So that means standard pressure. Okay, so our P2 in the same unit is going to be 101,325, and we're going pascals. So go 1.01325 times 10 to the 5th pascals, and T2 will be 273 Kelvin. So I'm all set up with my values, and I will need to calculate V2. But what I want you to pay attention to here is the question is actually asking what is the volume of air at STP that an individual breathes in one day. The information that I was just given is in terms of breaths per 1 minute. And so when we generate our value for the second volume, V2, we're going to have to equate that for an entire day. But we use normal factor level method of dimensional analysis in the exact same way that we have all year. So we are still using the combined gas law. This is the last prep problem for the combined gas law. Let's solve for V2. And so we have V2 is equal to T2 multiplied by P1 multiplied by V1 divided by P2 multiplied by T1. And as we go to plug these numbers in, we have 273 kelvins. We have 9.95 times 10 to the 4th pascals. We have 505 centimeters cubed all over the 1.01325 times 10 to the 5th pascals multiplied by 293K. Now the kelvins will cancel out, so those are gone. Pascals will cancel out, so those are gone. The only unit I have left is cubic centimeters, which is handy because my answer should be a quantity of volume. So let's actually do some calculator work here. So we'll go in parentheses 273 multiplied by 9.95 times 505, then divide by 1.01325, and then that by 293. Now, as I look at these values, I'm seeing 3 significant figures with the exception of this value for pascals, but everything else is in 3 significant figures, so I'm going to report 462 cubic centimeters. Now, this is V2. Yeah, this is V2, but realize in the way that this question is being posed, this means that per breath, or should I say per breath we're getting 462 cubic centimeters. This is per 1 breath. We need to turn this into an entire day. Now, the question also tells us that we get about 15 breaths per minute, and since we're seeing this format, a quantity per quantity, we should be able to set this into some crosshairs and get the answer that we want. So let's start with the 462 centimeters cubed per 1 breath. All right, that's what we just generated to start. All right, and we are going to use the conversion factor of breaths per minute. Right, that way we'll be in volume per minute. We'll use another conversion factor to convert out of minutes and into hours. Use another conversion factor to convert out of hours into days. And then we'll be in volume per day. Now we get 15 breaths per 1 minute. We have 60 minutes per 1 hour. We have 24 hours per 1 day. Now notice this is going to give me a centimeters cubed per day, but we don't want centimeters cubed, we just want cubic centimeters. So I'm going to add one more conversion factor to convert out of the centimeters, right? Notice centimeters here and the centimeters here, I can get them to cancel, and per meter. Now I'm going to use a little trick to keep my math simple in my calculator. Now we know that this is cubic centimeters and I need them to cancel. I need to be in cubic meters. Now I'm going to put these quantities that I'm more familiar with in the parentheses because you guys know that when you multiply a meter by a meter by a meter, you get 1 meter cubed. And you know that when you multiply 100 centimeters by 100 centimeters by 100 centimeters, you get 1 million centimeters cubed. I'm going to plug this in this way just to keep my work just a little bit more neat. But this is going to allow me to cancel cubic centimeters and cubic centimeters, and I'll be in meters, cubic meters per day, right? The only units that I haven't crossed out here are cubic meters per day. So let's plug this in and see how this looks. So we have 462. Actually, let's get some parentheses in here. 462 times the 15 breaths times 60 minutes times 24. And now we're actually going to get to the bottom there. Okay, we're going to get to the bottom here, and it's going to be 100 and parentheses cubed. Nope. Mess that up. Cubed. And so I'm going to end up, again, with a unit of meters cubed per day. It's going to be 9.9, and I want 3 significant figures. So that 9 is going to turn that 7 into an 8. Gets a little bit messy, but 9.98 cubic meters per day.